All right. Happy Monday, everybody. So today we're just going to be doing a review. And I actually didn't get any questions from anybody. So if you're there, let me know if you have questions. All right. I see your question in the chat. Give me 1 second to pull up that homework. So I assume you mean questions 6 and 7 on the latest homework, right? On chapter 9 homework. So these two, correct? All right, so pH. So let's just think back. So pH, we said, is the negative log of the H plus concentration or hydronium. Oh, not these. Is it this 6 and 7 then? Okay, page 4. And so now we're looking at these buffer solutions. And so I'm going to flip back to the notes for a second because I like my formula better. Not that it matters. It's just my brain is programmed to this formula. So this is where we would get the Henderson-Hasselbalch equation. So pH is equal to pKa plus our log. And this should be conjugate base salt. And we'll dissect this into problem. And then over acid. And again, it's plus sign because it's base over acid. So I'm going to start by copying that. And so they have, we'll ignore this for now. Yeah, so this is the same formula. So pH equals pKa, but then it's minus because they have acid over base. So I just want to point that out again. That's why mine's a plus sign. Theirs is a minus sign. And so using our formula, again, it shouldn't matter. And so they didn't tell us the pKa of acetic acid. Let me see if it was anywhere else in the homework. And so maybe that's the first difficulty, is that you weren't given this. And so now we need to find the pKa of acetic acid. And it should be in our chart. And so this would just be something you would have to look up. And so on an exam, I would give you the pKa's that you need to know. Otherwise, so I'm going to poke around in our notes because it should be here. So acetic acid, and then we have the pKa and the Ka. So our acetic acid is 4.74. In worst case, you can just ask Google. And so if you just Google pKa of acetic acid, it would also give you at least a similar answer. So Google pulls up 4.76. I'd said 4.74. So it's fine if there's some discrepancy. So I'll use 4.74. And now we can look and identify who's who. So acetic acid, so this is our acid. Sodium acetate, so that's going to be the base. So that's the amount we put in. And so now I plug this into our formula. So our pH is equal to 4.74 plus my log. And again, I'm using base over acid. So then base 0.1 amount over 0.15. And so now we have to plug this in. And so firing this up. So 4.74 plus my log, 0.1 over 0.15. And so I get 4.56 for the pH there. And we could also test this and do this in reverse. So if you did the other formula, so minus our log, and then it'd be the opposite, so acid over base. And we'll just see. Oops. Oh, because I plugged in. Okay. Sorry about that. Didn't mean to cause panic. I lost a decimal point there. And so you still get 4.56 either way, depending on your formula. Yeah. And then so the same thing. And so we can repeat this. And so now we have to figure out. So we have sodium carbonate and then sodium bicarbonate. And so now we need to look up the pKa. So probably the pKa of sodium bicarbonate. I'm just seeing if we had it. So for this one, we might have to ask the internet. And for this one, let's see. Looks like it's 10 to the pKa. So this one, because you have to be careful because it has two pKa's, and we want kind of the second one because it should be bicarbonate to carbonate. So this would be 10.3. And so again, on an exam, I would give that to you. And so then we can go our 10.3 plus our log. And then this is our base comparatively speaking. So this is sodium bicarbonate, which could go on. So that 6.3 is for the carbonic acid to bicarbonate because it has kind of 3 chains in there. So this is the first dissociation. So that's the 6.3. And then the 10.3 is the one that we want as it goes from bicarbonate to carbonate. And then the log. So I want to do so plus base over acid. So this is our base over our, again, comparative acid species since it has one more proton. So we can compare protons and then plug it in. And if you come across the exam and there is a question like this and you aren't given the pKa's, just email me and I can help you. Or, if you like use Google and say, hey, I picked this pKa, just let me know and I can always fix, your answer. And so we should get about 10.6 then from that. Awesome. No problem. Let me know if there are other questions or just other topics in general you want me to go over as well. This is just our open review time. Yeah, we can look at that. Is it the titration lab? Yeah, the acids and bases. I should be printing it over. Oh. And then just let me know which one it is. All right, so this is a good one. All right, so you said you had the equation. Sorry, my cat was climbing on me. So we have sodium hydroxide plus our acetic acid gives us water and sodium acetate. And so now this is a stoichiometry problem. And so first we're given, looks like moles of sodium hydroxide. So we can calculate that. Similarity is moles over liters. So we can multiply it by our volume to get us moles of NaOH. So let's do that. So again, I just divided by 1,000, so it's in liters. Now multiply it by the molarity, which is moles over liters. So liters cancels. And let me just type that in. So now we should have this many moles of sodium hydroxide. So 1.575 times 10 to the negative third moles. So does that make sense so far? And then once we're here, right, we can go back to your equation, and you said they're in a 1-to-1 ratio from your balanced equation. And so we could set up our conversion factor formally, but because it's just 1-to-1, 10 to the negative third, I just converted from the calculator. Oops. So it wrote it as 0.00. So I just go over 1, 2, 3. So that's how I know it's 10 to the negative third. So that's how I rewrote it like that. You could keep it as this 0.001575. And just me personally, I get squirrely if I look too many zeros in the front. And so once you're here and you recognize this 1-to-1 ratio, then we can say that this is the same moles as our acetic acid. So we have 1.575 times 10 to the negative third moles of vinegar or acetic acid. And then the last step, so now we have moles, then we can find our molecular weight of acetic acid, which we can take the cheating route. And right, so we always want to know how to add it manually. So of course we could add up all our atoms, but I just felt like looking it up today. So 60.052 grams per mole. Let me add a little space if I can here. And so that's our, again, molecular weight of acetic acid. And so we have moles, so we can multiply those two together to leave us with grams. So 1.575 times 10 to the negative third. And again, that's moles of acetic acid times the molecular weight of acetic acid. So grams per mole, so moles cancels. And let me punch that in. So now times. So again, you could have left it in your calculator like that. And so now I have 0.0945 grams for the mass of vinegar in that sample. And I'll round it to 0.0946 grams. So let me know if that makes sense. I'll just leave that for a second. So it's still here. I'm just putting on a little thinking music, hopefully. And just let me know if you have other questions about anything or anything else you want to go over. I'll be probably streaming until 10:50, 11ish officially, but I'm happy to keep going if there are questions. So keep the questions coming if you want to keep the stream going past 11. Of course. And just let me know if there are any other questions. You can always reach me by email as well. And if there are any other questions, I'm more than happy to go over something. Yeah, otherwise, good luck on finals. And I am, again, always available to meet over Zoom or in person if that works for people. So, whatever people need to get through this last week. So, woo! Awesome job, everybody. Yeah, we can look at question 8 on the homework. So just what property makes it different from a non-buffer solution? And this one. What did you put for this one? All right, sorry, I was waiting to see what you would type. But basically, if this is a question, there's a couple of thoughts with what it's getting at. So the big thing is it resists a change in pH. And so that's kind of like the answer. But then we can add to it, right, that kind of the key component of a buffer solution is a weak acid and then its corresponding conjugate base. Are we looking at the right 8? Am I looking at the right 8? Trying to see if there are other 8s. Is this? Oh, the lab. Sorry, the lab homework. My bad. I was reading. So this one, right? The neutralization. And so let's walk through it, and you can always flag me down if something seems different. And so let's go through this one. And so now start with your balanced equation. And so, of course, we have a little bit of a difference because now we have 2 equivalents of sodium hydroxide are needed for our sulfuric acid. And then 2 equivalents of water. And so now let's walk through it together. So same thing like we did before, convert our volume to liters, multiply it by our molarity to get moles over liters. And so that should give us 0.00325. And now we're at moles of sodium hydroxide. And so then it says, well, we're trying to get to weight for volume. So eventually, right, we need to get grams over milliliters. So let's get grams. And except now we're in a 2-to-1 ratio. And I'll set up the conversion factor for this one. And so basically, for every 2 moles of NaOH, that neutralizes 1 of sulfuric. So now we have half. Let me pull up my calculator. So 0.00325 divided by 2 now. And so that's moles of sulfuric. So did you get this at least? So this is a good kind of stopping checkpoint right there. And then I'm going to look up the molecular weight of sulfuric acid. And so sulfuric acid, 98.079. And so now let's go ahead and multiply that to give us grams. So times 90.079. And so now I have this answer. And so we should have 0.146 grams of sulfuric acid in the sample, which would give us, so divided by 3 mils. And so that gives us, so times 100. So 4.8% weight per volume. All right, let me know how that looks. I feel like the stream got delayed somehow, even though I try to use low latency. So I'm going to keep hanging around. Awesome. Any more questions on the lab or anything else? All right, I'm going to turn back on our background music. So I'll probably stream till 11 and just kind of see if anybody asks any more questions before the 11 o'clock mark. And if not, I'll probably sign off and you can, again, email me. Otherwise, we can keep this stream going as long as there are questions. All right. Thanks again. So I will be ending the stream. Like I said, I don't see any more last minute questions. So I'll be signing off, but please feel free to reach out to me by email if you want to set up an appointment. I'm more than happy to set up an appointment anytime this week. Just email me and I can work with your schedule. I know people work and I'm more than happy to work around your time. Thanks again. It has been an awesome quarter. I really appreciate y'all. I know it's difficult doing the online classes, but I really appreciate y'all working hard, staying with it, and, really doing a good job. So thanks again, everybody. I really appreciate it. So have a wonderful rest of your finals week, and thank you so much. Bye.